Welcome back. Now let's talk about the calculation aspect of these questions. And the calculation aspect says on average, now on average, 25.5 centimeter cube, 22.5 centimeter cube of 0.10 molar of KMnO4 solution. Now it means on average now the volume of standard KMnO4 with a known concentration of 0.010 molar will require to complete the reaction which is titration reaction of 25 centimeter cube solution of iron 2 solution. Now to determine the iron content in the tablet solution, 22.5 centimeter cube volume of standard KMnO4 were used. So now, meaning that for KMnO4, which is our standard, the volume that was used was V1 equal to 22.5 centimeter cube. That is the average volume that was used, average volume. Know that it is average volume. I call it V1 because I take KMnO4 as for solution. So it's 22.5 centimeter cube. And the concentration of KMnO4 that was given is M1, which is 0.10 molar. Now, for the other solution that we are titrating, for that solution that we are taking, that we are actually determining, which is iron 2 solution, I call it V2. The volume that was pipette out is called V2. So I tag it V2, 0.25.0 centimeter cube. And the concentration, we haven't known it yet because that's what we are looking for. The quantity of iron content in the tablet is what we are looking for. So that's the concentration of the iron in the iron tablet is what we are looking for. So I call it M2. We call it concentration. So M2. So now the question now says calculate the number of moles of M2 plus M7 plus ions. Calculate the number of moles of what? Of manganese ion. You are asked to calculate the number of moles of manganese 7 ion. So that one is easy to calculate. Calculate the number of moles of manganese 7 ion. Now, meaning that we are talking about this figure 1. We are asked to what? Calculate the number of moles of manganese 7 ions. Where is manganese 7 ion coming from? It's coming from this. It's coming from this KMnO4. So if you don't know where manganese 7 ion, the oxidation number of manganese here is 7. If you calculate it, you are going to get 7. So the manganese 7 here is 7 plus. So that's why. So when they're asking you to calculate the number of moles, they are talking about the number of moles of KMnO4 itself. So don't be confused. That's why many students were like, okay, what did I get was M7 ion here? M7 ion is actually the oxidation state of manganese. So instead of since I have known that the oxidation state of manganese is this, so I'm going to look for the concentration, the number of moles of KMnO4 itself. So if I get the number of moles of KMnO4, I've already gotten the number of moles of manganese 7 ion. So what I'm going to do is that, okay, if that be the case, you know that molarity here is same thing as moles over volume in liter, which is same as dm cube, in liter, which is same as dm cube. So and we are given molarity to be 0.1, but this volume must be in in liters. So meaning I'm going to convert this. And how do I convert this? So meaning that the volume given here, because I'm trying to calculate the number of moles. Molarity is equal to moles over volume. So definitely moles, number of moles will be molarity times volume. And this volume must be in liter. So what I'm going to do is that my moles now, number of moles now, which I call moles, which is going to be what? What's my molarity? My molarity is 0.010 times, what's my volume? My volume is 22.5. Then divided by 1000 in liters. You can see that we have a long. So what I'm going to have now is, if I multiply this, I'm going to be having, in standard form, I don't want to take much of my time anyway, but let me just use calculator. I've just use my mathematics skills, but I don't want to waste your time. So 0.010 times 22.5 divided by 1000. So you are having 1, 2, 3, you're having 2.25 times 10 raised to the power what? 2.25 times 10 raised to the power minus 3 moles. That is the number of moles. Don't forget, this is what we're looking for. This is what we're asked to calculate for this. So it's not that far-fetched. So calculate the number of moles of iron 2 present. Now, see how we calculate the number of moles for iron. See how we calculate the number of moles for Mn7+. We actually use molarity equal to moles over volume. The same thing is applicable to iron 2 solution. You must use moles over volume. But the question now comes, how do we get the molarity, which is N2 of iron 2? The molarity of iron 7 is actually easy to calculate because this concentration has been given right from the question. But that of iron 2 is yet to be found out. So it is our responsibility to get the concentration of the ion, and then from the concentration of ion we get the what? The number of moles of iron. So the first step to do is to get the what? The concentration of the ion. The concentration of the ion. So I'm going to get the concentration of the ion first, which is what I'm going to use. What are we going to use to get the concentration of the ion first? Concentration of the iron 2 first, which is known as molarity what? 2. Don't forget, this is molarity 1. Molarity 1. So now molarity 2 can be gotten using this formula. M1 V1 over M2 V2 equal to N1 over N2. I'll teach you how to use this formula. This is what we call formula, quantitative formula in volumetric analysis. So what is M1? M1 is known, V1 is known, M2 is what we're looking for, V2 is known. What is N1? What is N2? Now you now come to this one. This is what we call manganese is N1. So this is going to be N1. The number that is at the back here is what we know as what? Number of moles. That is N1. So N1 here is 1 because, I hope you see this, I need to use another color. N1 is equal to 1 here. Why? Because it takes 1 mole of manganese to react with 5 moles of iron. So our N2 here is 5. That's how to get it. Our N1 is what? Is 1. Our N2 is 5. So we are just going to apply them here. So what we are going to get in application is that M1 is going to be 0.01 times V1 V1 is 22.5 all over M2 is what we are looking for. 22 and V2 is 25.0 equal to N1 is 1 and N2 is 1 and N2 is 5 according to the chemical equation. So you always get your N from the chemical equation. So by doing cross multiplication mathematically, you cross this and this. When you cross this and this is going to be what? N2 times 25 equal to 5 times 0.101 times 22.5. Divide both sides by 25. I guess this one is a 1, so I don't include the 1. So we divide both sides by 25. So that's the mathematical aspect of this. So when you do that, what do you get? So we have 5 times 0.01 times 22.5 divided by 25. So we have, in calculations, we have the volume of the molarity of L2 is 0.045 molarities. So that is the molarity for what? For M2. So I won't get the molarity. Don't forget, we are looking for number of moles of F2. Number of moles, not molarity, but we need the number of moles to get the molarity. We need the what? We need the what? We need the molarity to get the number of moles. We need the molarity of what? Of ion to get the number of what? Moles. So I haven't gotten the molarity for the what? For the ion 2 solution. The question says calculate the number of moles. Don't forget, the question says calculate the number of moles of ion 2 present in 250 centimeter cube, of solution. So we need to take note of that. So we just get the what? M2, which is the molarity of ion solution. We have to calculate the moles. So we have to use M2. Don't forget, molarity itself is moles over volume. Molarity itself is mole over volume. So because we are dealing with what? Ion 2, I'm going to be using M2 equal to moles all over volume. So which is, the volume here must be in liter. Take note of that, it's going to be in liter. So because molarity is moles over volume in liter. So to get the moles now, moles is going to be, which is molarity times the volume, which I will represent as V in liter. So now the number of moles will now be the molarity that we just got, which is 0.045 multiplied by the volume of solution of ion 2, which is 250, divided by 1000. To take centimeter cube to liter, we divide by 1000. So that's how we're having that one. So if I press my calculator, this is going to be 0.045 times 250 divided by 1000. So I'm going to be getting 0.01125 moles. Don't forget the unit. Unit is very, very important. But if I take it standard form, I'm going to be getting 1, 2. So this is going to be 1.125 times 10 raised to power minus 2, right? Moles. So this is the number of moles of ion 2. This is the number of moles of ion 2. I'm just putting this is the percent of ion 2 in volume, in what? In 250 volumetric flux. This is the number of moles. So now the question now says calculate. Look at the question. Next question. The next question says calculate average mass in one tablet. Calculate the average mass in one tablet. Now, average mass of iron 2 in one tablet. In one tablet, you know, we have 6 tablets before we grant 6 tablets together to use for an experiment. But the question says calculate the average mass in one tablet, the average of mass of iron, that is the iron content that's going to be estimated in one tablet. So what we're going to do is that we are going to get the iron content first in what? In the iron content first in the 6 tablets. What are the amount of iron in 6 tablets before we can now get the iron content in each tablet? So to do that, what we are going to do is that we are going to use the word moles over. We are going to use the formula for moles equal to mass over molar mass. So what is mass over molar mass? The mass of iron 2 in 6 tablets. In 6 tablets, don't forget. We are actually using mass over molar mass, but we are going to be getting the mass of iron 2 in 6 tablets now, even though we are using mass over molar mass. So I'm just trying to include the iron 2 in 6 tablets so that you know what we are looking for now. So to get the mass of iron 2 in 6 tablets, so I'll calculate the mass of iron 2 in 6 tablets now. It's going to be the moles that we get times the molar mass of iron 2, right? Of iron, molar mass of iron. So we are going to be what's the mass? Mass is going to be, what's the number of moles here? Is 1.125 times 10 raised to power minus 2 times iron. Molar mass, atomic mass, we don't call it molar mass anyway because it is one. It is one element, so we call it atomic mass, but you can take it as molar mass if you want to. So 56, so this is going to be times 56, 1.1 2525 times 10 raised to power minus 2 times 56. So we are getting 0.63 gram for the 6 tablets. Don't forget, this is for the 6 tablets. So mass of iron 2 now in one tablet, please note, in one tablet, I can clean this now, will be equal to 0.63 divided by 6. It's as simple as that. So 0.63 divided by 6, 0.63. 0.63 divided by 6 around 0.1. Yeah. So the mass of iron 2 in one tablet is going to be what? One tablet is going to be 0.105 gram. So the question has a calculate percentage by mass. Calculate the percentage by mass of iron 2 in one tablet. That one is very simple. Percentage by mass, just take 1, which is the final step now. Just take the percentage by mass now of iron 2 in one tablet. In one tablet. Percentage by mass of iron 2 in one tablet. The percentage by mass of iron 2 in one tablet. You have to be very careful. Mass of iron 2 in one tablet. Percentage by mass of iron 2 in one tablet. What is the total mass of 6 iron? This is it. So what you are going to do is that you are going to divide this by 6 to get the actual mass of one tablet. So, or you can do it like this. Since you've gotten 63 gram, 0.63, sorry, 0.63 for the mass of tablet in 6. So what we are going to do is just, we are going to say, okay, if I've gotten this one is going to be mass of 6 tablets now. Mass of 6 tablets over the total mass. Total mass, okay, total mass of 6 tablets. I'll coin this very well. Mass of iron 2 in 6 tablets. Over total mass of iron 6 over total mass of 6 tablets times 100. That's the best way you can do it, because if you say you are going to be dividing it one by one, you are still going to get the same answer at the end of the day. So I just use that one, so that since we are going to have equal, so you can do this straightforward. There are two ways to do it. It's either you use this method, or you use this 0.1 divided by this, and then you're still going to arrive at the same answer. So, but let me use the fastest one, which is this one. This one is the most fastest one. So, not just to save our time. So what I'm gonna have here is coming from up down is 0.63 over 2.496 times 100. 2.496 times 100, so times 100. So that should be 25%. 25.24%. So the second method I say you can do is that, since we know that each tablet is 0.1, each mass of one tablet is 0.1. I'm just going to explain this 1 gram, right? So you can also say divide this one by 6 as well. You can divide this one by 6 to know mass of each tablet. So this one will be divided by 6, which I say is going to give us the same thing anyway. We divide this one by 6, it's just the second method. I'm not going to be presiding on it. Just a mathematical. This one is going to be 0.416. So if we divide this one by this times 100, you're still going to get the same answer. 0.15 gram divided by 0.416 times 100. Let's see if that is correct. As a mathematics student, divided by 0.416. See, we get the same answer. So that's the two methods. We are still going to have 25.24%. So that's that about that. So the mass of what? Of percentage amount of iron in one tablet is actually this. So that's that about today's class.